So now we're going to be going over lesson 2. We're going to be talking about what is an equivalent ratio. And when we do that, what we're going to do is we're going to develop a better understanding about this idea of relationship that we were talking about in lesson 1. Now, let's start off with a quick review of what we said a ratio was. So we said a ratio is a quantitative relationship between two amounts. And I had a lot of students in the last lesson who said, yeah, but it looks like we're just writing down the numbers we see. You're right. We were last lesson. And what we're going to be doing today is we're going to be talking about what does that relationship that we're observing really mean? And can we find ratios that have the same relationship, which are called equivalent ratios? So formally defined, equivalent ratios are two or more ratios that have the same value. For instance, here I'm going to say I'm running a pet shop, and there's a rule that says that for every 3 dogs I have to have 2 water bowls to make sure that the dogs are hydrated enough. So if I'm looking at the ratio of dogs to water bowls, well then I would have 3 dogs for every 2 water bowls, or 2 water bowls for every 3 dogs, however you want to look at it. Now, does that mean that the only thing I can have in my pet store is 3 dogs and 2 water bowls? No, of course not. We know that. It just means that for every 3 that I have to have 2 water bowls. So if I wanted to say, okay, well, let's say that I get a puppy shipment in, and now I have another set of 3 dogs. Then I'm going to need 2 more puppy bowls. So an equivalent ratio to 3 to 2 is going to be 6 to 4. Now, even though these are different numbers, they have the same value. As you can see, for every 3, there's 2. Whether it's a 3 to 2 or a 6 to 4, it has the same relationship. And I could further this even more and just say, okay, we'll say that I had 3 more dogs. Well, now the ratio is going to become a 9 to 6 ratio, which is also equivalent in value, but not the same number. And we could continue this on, and we could say 12 to 8, and then I could say 15 to 10, and this could go on and on and on. And all of these have the same relationship. I don't think I have any more dogs to continue on, but all of these have the same relationship. Even though they're different numbers and technically different ratios, they're equivalent ratios because they have the same value. Now over here, this table that we made, this is going to be called This is going to be called a ratio table. And this is going to be very important later on in the unit. So a ratio table is just where we can put equivalent ratios that allows us to explore the relationship. Okay, so now we've seen what equivalent ratios are. We've put them into a table so that we can organize them and so that later we can look at patterns and how they relate to each other. Now I just want to kind of show you how you can see ratios in tape diagrams. So here we have 5 stars to 3 circles. And I also have drawn a tape diagram to represent that. So as you can see, I have 5 spaces. See here, 1, 2, 3, 4, 5 to represent my stars. And then I also have 1, 2, 3 spaces to represent my circles. Now, the first ratio that I have that's apparent to see is that I have 5 stars for every 3 circles. Now, if I have a 5 to 3 ratio, that means that each one of these represents 1. But for ratios and equivalent ratios, they don't always have to represent 1. Because we know from our last example that an equivalent ratio would be 10 to 6. Now, if this was 10 and 6, that would mean, let me erase these really quick. That would mean that each one of my spaces would represent 2. Now, it's important to notice that I'm saying that each one of my divides, each one of my spaces represents the same amount. And it'll always be that way. So if I change, and I don't always have to go in order here. If I want to change, get my eraser out. Maybe I want to change this to, we'll say I want these to represent 4 or 5. Let's do 5. Each one of my divides is going to be a representation of a 5 unit. Well, then now this ratio is going to be 25 to 15. And I could keep going and going and going, filling this up with ratios that are equivalent. But the important part to see is that when we're going to be using tape diagrams, it's important to keep in mind that each one of my divides have to be equal. All right, so let's keep going on this. Let's create some more. I could also say that this could be 50 and 30, and that would mean that each of these would be 10. Lost my little point there. So then these would be 10. And it really doesn't matter what number I put in here as long as it's the same, because it has to maintain that same 5 to 3 ratio. Why don't we do the last one? Why don't we do 100? That'll make it easier to finish this video up. Do 100, which will make this one 500 to 300. All right, so that pretty much sums up the lesson. We've talked about what is an equivalent ratio, which we've said is they are different ratios that have the same value. We've looked at the 2 different ways, or 2 different tools, that can help us understand ratios, which is going to be a ratio table and a tape diagram. In our next lesson, what we're going to be doing is taking these tools and our understanding of ratio and equivalent ratio and solving real-world problems. So it's really important that we have this foundation understood. Make sure to go underneath the video and do some extra practice problems if you're feeling unconfident in this, or if you need a little extra practice. All right, I'll talk to you next time.